Welcome to Day 4 of Daily AI Wizard, your 20-minute journey to mastering AI. I'm Anastasia, your AI guide, here to make learning AI simple and fun. Today, we're diving into the basics of how machine learning works, a key part of AI that powers many smart systems. We'll explore the process, types, and key concepts with a demo to bring it all to life. Let's get started. Before we begin, let's recap Day 3. We learned that AI is the broad field of creating intelligent systems. Machine learning, or ML, is a subset of AI that learns from data, and deep learning is a subset of ML that uses neural networks. We also saw Sophia demonstrate machine learning with Teachable Machine, classifying cats and dogs. I hope you tried it yourself and shared your results in the comments. Now let's dive deeper into how machine learning works. Today we'll cover the basics of machine learning. We'll start with a quick review of what machine learning is, then explore how it works by walking through the process. We'll look at the three main types of ML: supervised, unsupervised, and reinforcement, and introduce key concepts like data, training, and prediction. Plus, Sophia will join us for a demo to show a simple ML prediction in action. Let's get to it. Let's quickly review what machine learning is, since we touched on it in Day 3. Machine learning, or ML, is a subset of AI where machines learn from data without being explicitly programmed. Instead of writing rules, we give ML systems data, and they find patterns themselves. For example, spam filters learn from your emails to decide what's spam. ML is the foundation of many AI applications, and today we'll see how it works under the hood. How does machine learning work? It follows a simple process with 4 main steps. First, we collect data to teach the machine. Then, we train the model using that data. Next, we test the model to see how well it learned. Finally, we use the model to make predictions on new data. It's a cycle of learning and improving, and we'll break down each step to understand how ML brings intelligence to machines. The first step in machine learning is to collect data. It's the foundation of ML. Data can be anything: images, text, numbers, or more. For example, in our Day 3 demo, Sophia used cat and dog images to train a model. The quality and quantity of data matter a lot. Good, diverse data helps the model learn better, while poor data can lead to bad results. It's like giving a student the right books to study from. Step 2 is training the model. This is where the model learns patterns from the data using algorithms like decision trees or neural networks. For example, a spam filter might learn to identify spam emails by studying patterns in your inbox. The goal of training is to minimize errors and maximize accuracy, so the model gets better at its task. It's like practicing a skill. The more you practice, the better you get. Step 3 is testing the model. We need to check how well the model learned, so we use separate data that wasn't used in training. For example, in our cat and dog demo, we tested the model with new images to see if it could correctly identify them. We evaluate the model's accuracy and adjust if needed, like tweaking a recipe after tasting it to make it just right. The final step is making predictions. Once the model is trained and tested, we use it on new data to make decisions. For example, a spam filter predicts if a new email is spam or not. ML models often improve over time as they get more data, making them more accurate. This is where machine learning starts being used in the real world, solving problems and making our lives easier. Now, let's revisit the 3 main types of machine learning, which we introduced in Day 3. They are supervised learning, unsupervised learning, and reinforcement learning. Each type has unique uses and works differently depending on the data and task. We'll explore each one to understand how they fit into the ML process we just learned about. First up is supervised learning. This type uses labeled data, meaning we give the model inputs and the correct outputs. The model learns to predict outputs from inputs by finding patterns. For example, to predict house prices, we give the model data like house size as the input and the price as the output. It's like teaching a child with examples. This is a cat, this is a dog, so they can learn to identify them. Supervised learning is used in many applications. For example, spam detection labels emails as spam or not spam to train the model. Weather forecasting uses labeled data like past temperatures to predict the future, and image classification, like our cat and dog demo, labels images to teach the model. Supervised learning is widely used in machine learning because it's so effective for tasks with clear labels. Next is unsupervised learning. This type uses unlabeled data, meaning there are no correct outputs provided. The model finds patterns or groups in the data on its own. For example, it might group customers by their buying habits to help a store understand its audience. Unsupervised learning is like exploring without a guide. The model discovers hidden patterns by itself, which can be very powerful. Unsupervised learning has many uses. Market segmentation groups customers based on behavior, like who buys similar products. Anomaly detection, such as spotting fraud, finds unusual patterns in data. Recommendation systems, like suggesting similar products on Amazon, also use unsupervised learning to find patterns. It's great for discovering hidden patterns in data when we don't have labels to guide us. The third type is reinforcement learning. This method learns through trial and error, using rewards and penalties to improve. For example, a robot learning to walk might get a reward for taking a step and a penalty for falling. It's like training a pet with treats. The model learns by trying different actions and improving based on feedback. Reinforcement learning is great for tasks that need decision-making. Reinforcement learning is used in exciting applications. Game-playing AI, like AlphaGo, which beat a world champion in Go, learns by playing millions of games and getting rewards for winning. Robotics uses it to teach robots tasks like picking objects. Even self-driving cars use reinforcement learning to navigate traffic by learning from rewards. It's all about decision-making, making this type of ML perfect for dynamic environments. Let's talk about a key concept in machine learning: features and labels. Features are the inputs we give the model, like the size of a house or the text of an email. Labels are the outputs we want to predict, like the house price or whether the email is spam. These are used in supervised learning to teach the model. For example, in our cat and dog demo, the features were the pet images, and the labels were cat or dog. Another key concept is training and testing data. Training data is what we use to teach the model. It's the study material. Testing data is separate and used to evaluate how well the model learned. A common split is 80% for training and 20% for testing. This split helps avoid overfitting, where the model memorizes the data instead of learning general patterns. It's like studying for a test, but saving some questions to check your understanding. Machine learning relies on algorithms, which are the rules the model uses to learn from data. Examples include decision trees, which make simple decisions like yes or no, and neural networks, which handle complex patterns, like in deep learning. The choice of algorithm depends on the task and data. For example, a simple task might use a decision tree, while a complex one might need a neural network. It's like picking the right tool for a job. To see machine learning in action, let's bring in Sophia for a demo. She'll use Orange, a free tool, to show how supervised learning can predict flower types using a famous dataset. This will help us understand the ML process in a real example. Over to you, Sophia.
Hi, I'm Sophia, your demo guide for DailyAIWizard. I'm using Orange, a free tool, with the Iris dataset, a classic in machine learning. The dataset has features like petal length and width, and the label is the flower type, like Iris setosa. See how the model predicts the flower type based on the features? That's supervised learning in action. Back to you, Anastasia.
Thanks, Sophia. That was a great demo. Let's break down how it worked. Orange used supervised learning with the Iris dataset. The steps were collect data, like petal length and width, train the model to learn patterns, and then predict the flower type for new data. Machine learning finds patterns in the data to make accurate predictions, just like we saw with the flowers. It's a simple but powerful process. Machine learning isn't without challenges. First, data quality matters. Poor data leads to poor results, like trying to learn from a blurry textbook. Overfitting is another issue, where the model memorizes the data instead of learning general patterns. ML can also be resource-intensive, needing significant computing power for large datasets. These challenges mean ML requires careful tuning to get the best results. Let's recap what we've learned today. Machine learning lets machines learn from data without explicit rules. The process involves collecting data, training a model, testing it, and making predictions. We explored 3 types: supervised, unsupervised, and reinforcement, and key concepts like features, labels, and training testing data. Here's your task. Try Orange with the Iris dataset yourself and share your prediction results in the comments. For more resources, visit wisdomacademy.ai to keep learning. That's it for Day 4, everyone. Thank you for joining me on this AI journey. I'm Anastasia, and I hope you enjoyed learning the basics of machine learning. If you found this lesson helpful, please give it a thumbs up, subscribe, and hit the bell for daily lessons. Tomorrow, we'll dive deeper into supervised learning. Let's hear from Sophia before we go.
I loved showing you Orange today, and I can't wait for more demos in this series. Day 5 is going to be amazing, so don't miss it. See you tomorrow, wizards!